Good morning, ladies and gentlemen of Precalculus, or ladies and Will, I should say. Angel, for some reason, is not with us today. Anyway, here we have in exercise 1 through 4, state the sign, positive or negative, of the sine, cosine, and tangent in the quadrant. I'm going to go over these really fast. And it's kind of like we said, this thing right here in quadrant 1. Remember this thing, all students take calculus? And which is not true, of course, but serves a purpose today. So we know that in quadrant 1, all trigonometric ratios are positive or greater than 0. And then what we have in problem 2, we're given quadrant 2, what is positive in quadrant 2? Sine. So sine theta is greater than 0, and the other major trigonometric ratios are negative, right? Yeah. And then we have this one here, quadrant 3.
Can you go back to number 1? You're going really fast. Yeah.
Everything is positive. So there it is. And so that's quadrant 2. Quadrant 3, what is positive in quadrant 3? Tangent. So tangent theta is positive in quadrant 3, and the other major trigonometric ratios are less than 0. So there was cosine, right? Cosine theta is also less than 0. And now quadrant 4, our last quadrant, what is positive in quadrant 4? Cosine. Cosine. Cosine theta is greater than 0, but tangent theta is less than 0, as is sine theta. And really that's all there is to 1 through 4. So it's just a quick review of which one? 2. Okay. 98.2? Okay. Okay, find the exact value for 5 through 10. So what we're getting is, what is the sine of pi over 6? And we get back to our unit circle trigonometry song, right? 0, 1/2, and square root of 2 over 2. That's what I'm telling you. Square root of 3 over 2 and 1. The sine is the height at any radian. So which angle is this? Yeah, it's this. It's the ring finger, right? Ring finger. And so what is the sine going to be? Square root of 1 over 2, which is 1/2. We're going to make quick work of these, okay? Okay, next, pi over 4. Okay, again, pi over 4.
Middle finger.
It's going to be middle finger, right? So I retract that, and tangent is square root of fingers, of these fingers, over square root of these fingers. So square root of 2 over square root of 2 is 1. But to me, the tangent is the one that's a little harder than the others. But in this instance, we have 1. Okay, next. Cosine of 2 pi over 3. Now, is 2 pi over 3 part of our standard acute angles? No, it's not. So what we have to do is we have to go ahead and sort of extrapolate our understanding a little bit. And what it is 2 pi over 3 is right up here, isn't it? And so what it is we have at 2 pi over 3, we have a reference angle, a reference triangle, where we have our over here we have negative 1/2 and 1, and over here at pi over 3 which is same as 60 degrees, I'll put comma 60 degrees, we have 1/2 and 1 here. So what is our answer for this one going to be? Negative 1/2, okay. There's some stereophonic chorus answer. So basically for these things, if you go ahead and find what the reference angle is, in this case we have our reference angle of 60 degrees, then you know what that cosine is there. The only question you have is this one going to be a negative or positive? And this thing's going to be negative or positive just depending on where it lies. Here in quadrant 2, our x is negative and our y is positive. And so that's why we're going to have a negative 1/2 for that over there, okay? Does that halfway make sense? No, not at all. But you know over here, Kaylee, right? You know over here in this quadrant here, 1, you have x positive, y positive. Here in quadrant 2, you have x negative, y positive. Here in quadrant 3, you have negative, comma negative. In quadrant 4, you have positive, comma negative. Okay, so that's going to be how the signs are for x and y. And what is x? What is x? Cosine is x. What is sine? Y is sine. And then tangent is what? Y over x. Or sine over cosine. Okay? Let's go on to number 8. Okay, now we have sine of the same angle. So let's go back to this drawing here. What's our sine going to be over here? Is, first of all, is sine going to be positive or negative here for this one? Sine will be positive, right? But cosine is negative. And so here we have square root of 3 over 2. So what is our answer going to be here? Square root of 3 over 2. Oops, got the wrong thing here. Hit the wrong button. Okay, yes. So this is going to be square root of 3 over 2, right?
Yes.
And you could read that directly off your unit circle, can't you?
Yes.
Okay, sine of negative pi over 6 is?
Square root of 0. Negative square root of 0.
I thought it's 4/2. It'll be negative 1/2.
Yeah, it'll be negative 1/2. And let's talk about why that is the case. Yeah, let's talk about that. Because what it is, we have our negative 30 degrees right here. So this is negative 30 degrees, which is equivalent to negative pi over 6. And here's our reference. So this is our reference angle. So our reference angle equals 30 degrees. So here's our reference angle right here. And then we have over here 1/2 over 1. So we have our reference angles, sine is 1/2 over 1, but we're down here in quadrant 4, so what is it going to be? Negative 1/2. Okay, so that's just using our reference angles. And our reference angle is always going to be positive, is always going to be between 0 and 90 degrees. Last one here, number 10, cosine of negative pi over 3. So now we're getting, well actually it's another one. So we have negative pi over 3. So cosine of negative pi over 3, we're looking like this, right? And what reference angle is this going to be?
60.
It'll be a 60 degree reference angle right here. So Will is right. And so, and in the unit circle, first quadrant is up here. Okay, that's 60 degrees. That's negative. So what is this one going to be over here?
Negative 1 over 2. Negative 1.
And it's just 1/2 because in quadrant 3 is, quadrant
Kidding.
4.
And 1/2.
Yeah, so that's right. So really these exercises here are just mostly about kind of using reference angles and keeping track of what's positive and negative, right? So that's pretty simple, right? Okay. Now what we're doing here on these exercises on the back page, this one here is a quantum leap of degree of difficulty. And the reason it is because we're doing we're doing something called a, what do we call this little -1 here? A what?
Inverse.
Thank you. We call this an inverse function. And Kayla was the first one to recognize that, to mention that, so I'm going to recognize her on this. So that's an inverse function. And the thing that's really good is I appreciate that you recognize that notation as inverse notation. What else, did you just remember that from first semester, or how'd you
You use
remember?
it in what, in physics all the time?
Oh, in physics you're using it a lot? Okay, good. Fantastic. Good. Okay, now, so really, what our answer is, it's the answer to the question, what is the angle that produces a sine value of square root of 3 over 2? And I want to show you a couple things first. One is if I put in the calculator, I'm going to put sine x right here. I'm going to put sine x. And I can see that I'm in radians, right? And I'm going to go between negative pi over 2 and pi over, that's 2 pi. So I want negative pi over 2, not divided, not times. And over here we have pi over 2. And what happens is, our y minimum, I'm going to put negative 1.2, and I'm going to put 1.2 here. And so what this does, something is amiss. Oh, I know what it is. It's right here. I got to change my things to radians here. Here we go. There we go. So you see what happens to the value of sine?
Yep.
So what happens is the angle changes from negative pi over 2 to positive pi over 2, but our sine value will range from -1 to 1. I didn't get it right here. Let me go ahead and put y minimum right at -1. And y maximum at 1. Okay, so right here, we graph, this is what we see. So it goes right from -1 all the way up to 1. All right. But what we're doing here in this case, we're doing something different, is we're inputting the value of the trigonometric ratio. So in this case, we're going to go between negative pi over 2 all the way to pi over 2, or backwards. We're going to go between, I have it backwards here, we're going to go between -1 to 1, and we're going to range to from pi over here to negative pi over 2 here. And so we're going to get a different type of arrangement here. And what that looks like is, it's going to look something like this. And then to verify that in your calculator, you can go like this. We're just going to change it up here from -1 to 1, and from negative pi over 2 to pi over 2. And so we graph, we don't see it here, but we have to get the right function here. Okay, we're going to change that to inverse sine of x. So we go ahead and enter that graph. That's what it looks like. So we go ahead and put in the value of we're going to go ahead and put in this value of square root of 3 over 2, and I'll show you where that is. If we go to our calculator, square root of 3 over 2, table set, yeah. We're going to go to ask, and if we put in, go to here, we're going to put in negative square root of 3 over 2. Should get we should get that negative 1.047. That's going to be in radians. So negative point. Whoa, it's in radians. Negative 1.047. Times 180 over pi. Let's see what this is. I hope this is better than what. Yeah, so we get negative 60 degrees, right? So that's going to be, actually that's going to be positive 60 degrees because it's going to be 1.0. Anyway, that's the idea. I put in negative 1.047, I think I did, right? Yeah, it should be 1.047 times that. You should get positive 60 degrees. So yeah, that's it. So what is our answer going to be for this one? What's our exact value? It'll be 60 degrees or pi over 3 radians. And some of these are more difficult than the others, but I want to go ahead and pick people from the audience to help with this. Let me go. So do you understand how this works? No, I got 2 people nodding this way. Okay, basically what you're doing, what you can do, if you look at the unit circle, do you have your unit circle? Where's your unit? Do you have the unit circle? Let me see. One way to look at it is this. So you're looking right over here at your sine values, which are these y coordinates. And you see your square root of 3 over 2 right here. And the angle that associates, that produces that, is going to be 60 degrees or pi over 3 radians. So you kind of work backwards using that. Did you catch that, Carmen? So here it says inverse sine. What we're looking for is the angle that produces the sine. And here's your sine value, your sine or your y value, right? So here you see your sine is square root of 3 over 2, and that's going to be the angle it takes for that to happen is pi over 3 radians or 60 degrees. Okay. All right. Number 2, inverse sine of negative 1/2. Who's going to help us with that one? It's going to be open. Sixth, okay. Angel didn't make it today. All right, here we go. This one's going to be Emma or Carmen. It's going to be Emma. All right, Carmen. All right, Carmen. Carmen, what'd you get for this one? You should be able to read this off a unit circle is what you should be able to do.
Is it 220?
Okay, 210 degrees actually, yeah, 210 degrees would actually, Kinsey said 210 degrees, that's actually, could be a right answer, but what you're looking for is you're looking for between negative pi over 2 and pi over 2. So you're looking for your sine over here, that's where you see that negative 1/2 over there for sine. At how many degrees? 330 degrees. And this is exactly what someone, a very good student, I think Robert did that in 5th period. But what happens is you're defining the domain of this function between negative 90 degrees and 90 degrees is going to be your domain of this. And so really your answer here when you adjust it for that is going to be negative 30 degrees. Does that make sense? Because your domain of your inverse function is going to be defined. So you would instead say negative 30 degrees. Okay, or negative pi over 6 radians.
Would 5 pi over 6 look too?
5 pi over 6 would be positive sine, right?
So you're just-
Quadrant 2, the inverse sine is negative.
In quadrant 2, your sine is positive, right?
So if you look at your circle sheet, you only use the first quadrant.
Well, for inverse sine, use first and second quadrant. No, use first and fourth quadrant.
Oh, this side.
Yeah, the right side, okay? Now for cosine it's different. Cosine you got to use quadrants 1 and 2. But I don't know, we'll get to that cosine one here shortly. Okay, next. 3. Okay, inverse tangent of 0. So what angle produces a tangent of 0?
0, or 360.
Yeah, so I think we'll set it here pretty well, but Kate will have a chance to say it too.
0 and 360.
Yeah, 0. It's gonna be 0 degrees, and
Yeah, only the person's having this done since last over.
or 0 radians. And I'll show you another way you can find out, besides the way Will and others figured out, is that your tangent theta is equal to sine theta over cosine theta. So this coincidentally, and for a good reason, the tangent of 0 is going to be the same as sine of 0, because they're both going to be 0 at 0, right? So just, yeah, so 0. So that is our answer here. 0 degrees or 0 radians. Thank you. Okay, number 4, inverse cosine of 1. So what angle will produce a cosine value of 1? And Kinsey?
Oh, crap.
Oh crap, she said.
I think it's going to be 0 or 360.
It is.
Oh, so
Okay, and so, Kinsey, how can you do that even if your friends don't help you with it? How can you find that out?
if you just look up on this little handy-dandy thing right here, you
Beautiful,
can-
okay, so she tells me that's where she sees
Yeah.
x value equal to 1, so that's a correct answer. Good answer. Thank you.
You're welcome, Mr. G. Anytime.
And I appreciate that you have friends that help you too. That's a good thing.
Sometimes we just need some help.
That's true.
We study for your test on the way to our games, right, Jens?
Yeah.
Oh, yeah.
And sometimes you tell the truth too, right?
Not really, no.
No,
Actually, the
no,
teacher's
no,
standing in front of us.
Besides for some,
If it was Clark, I'd lie to him.
All right.
Didn't y'all write letters to Miss Mitchell and y'all?
Were y'all paid her? Trying to bribe her to come back?
All right,
Yes. How much you want to bet she kept the money?
here we go.
Y'all put like $20 in
I put like $1. No.
I can't help you.
Well, it just wanted to.
You lucky guy.
So here we have inverse cosine of 1/2. What is this going to be?
Is it 60 degrees?
Ah, she got a paper cut.
Oh, nobody cares.
Or I did that last
Or pi over 3.
Yeah, radians. Did you look that up off the unit circle? Is that how you did it?
Yeah.
Okay, that's fair. But that's, yeah, that's what it is. Okay. I'm gonna call on somebody here for number 6 in a minute.
Oh, no.
Okay, so,
Kenzie?
Kids are quick looking, so.
I'm gonna break you if you don't.
I've already broken. I mean, that wrist though.
I thought it was her leg. Her ankle.
No, it's gonna be her head, then her ankle, then her arm.
Emma's just focused.
I'm just gonna, you can't blame it on Mikey this time.
Guys,
Mr. G, did you know my knees are deformed?
Do you know her brain's formed too?
okay, next. Number 6.
So very nice.
That actually.
Okay, we got Will's number 6. All right, Will. Get Will for that. So Will gets pi over 4 radians, you say?
I didn't get that.
Could it be, how could you not?
Could it be
Mr.
like-
G gave it to us
Could it
on
be
the other
2
problems.
No, he's exactly right. And let's talk about this. Remember we have our little hand trick? The sine over cosine, right? And tangent is fingers, square root of fingers over square root of fingers. And so pi over 4, that's this one right here, right?
Yeah.
And so we have square root of 2 over square root of 2, which occurs right there at pi over 4 radians of 45 degrees. Thank you,
What
Will.
about the opposite of? Yeah, what about angle of 225?
Yeah, 225 here, let me show you this.
It's a negative and a negative, so it'd be a positive.
Yeah, so it's a negative, what it is, your reference angle is the same, right?
Yep.
And so your tangent is going to be plus or minus 1. So the only thing you have to consider yet is it going to be plus or minus? Well, you say quadrant 3, that would be minus over minus or plus, right?
Yeah. Yeah.
Okay. So if you go back to the reference angle and then think, is it going to be plus or minus? And that whole, all students take calculus can help you figure that part of it out.
I thought that's why it would be that way, because it is positive.
Yeah, uh-huh.
So would that not work?
Well, it would, except your normal, it would work except that for inverse, remember we're going to go between negative, because what it is, that's an instance where you have 2 outputs for a single input, right?
What?
Okay, you're going to have, so if you go from like negative pi over 2 to pi over 2, okay, negative pi over 2, pi over 2, here at 45 degrees, right here at pi over 4, our answer is going to be 1. It's going to be 0 here. So our tangent function, I'm going to draw it in red, our tangent function is going to look like this and go up to a vertical asymptote. And then negative is going to come down here. So we graph the tan function, it looks like this. But what it does here is it repeats itself. So if we go over here to 3 pi over 2, the thing is going to do it again, like this. Okay, so what happens is, if we turn it upside down, if we take that value of 1, that will occur here at pi over 4 radians, but will occur also over here at 5 pi over 4 radians. Is that right? Because we have a negative divided by a negative. But what we're doing is we're restricting the domain between negative pi over 2 to pi over 2, so this becomes a function. If we go outside of that, we could have an output value like you say, of 3 pi over 4, or 5 pi over 4, excuse me. And so what happens is, for inverse functions, we restrict the domain.
That's why you were making the graph small?
Yeah, that's why I was. So, well, that still is a good question. That's a really good question. All right, let's go on here to number 7. This one here, for inverse tangent of -1, we're about out of time. So this one here is going to be negative pi over 4 radians, or negative 45 degrees. Okay? This one here, negative square root of 3 over 2, that's going to occur at negative 30 degrees. No, negative, it's going to be at 150 degrees, excuse me. And in this case, our domain is between 0 and 180. And then this one here is really tricky. I actually made a mistake on this one that Karina fixed for me after the class. What it is this is sort of a trick thing. If you get this here, it's going to be negative square root of 2 over 2 is what's going to be. And this occurs at negative 45 degrees, or negative pi over 4 radians. And then 10, we have square root of fingers over fingers. Okay, it's going to be we have square root of fingers over fingers, we get square root of 3 over 1. So this is going to be at negative
60.
negative pi over 3, or negative 60 degrees. Negative pi over 3 or negative 60 degrees, or negative 60 degrees.
You just turn these in?
Yeah, you can turn them in. And then cosine of 0, that's going to be value at equals pi over 2 radians, or 90 degrees. And the last one's going to be sine. This one's inverse sine of 1 is going to be at pi over 2 radians, or 90 degrees. So that's it. Thanks.